Hey there, YouTube friends. Welcome back to another video. Today, we're going to talk about a topic that's important in the world of electrical engineering, apparent power. If you're not familiar with what apparent power is or why it's important, don't worry, we're going to break it down in a way that's easy to understand. So, let's get started. First things first, what is apparent power? Well, when we talk about electrical systems, we often refer to three types of power: real power, reactive power, and apparent power. Real power is the power that's actually consumed by a load and is measured in watts. Reactive power is the power that's stored and released by reactive components like capacitors and inductors, and is measured in volt-amperes reactive, VAR. Finally, apparent power is the combination of real and reactive power, and is measured in volt-amperes, VA. Now that we know what apparent power is, let's talk about why it's important. The short answer is that apparent power tells us how much power is required to run a particular load. In other words, it's a way for us to determine the total power that's being consumed by an electrical system. To understand why this is important, let's think about a hypothetical scenario. Say you have a 100-watt light bulb that's connected to a 120-volt AC power source. Based on this information, you might assume that the bulb is consuming 100 watts of power. However, if we were to measure the apparent power of the system, we would see that it's actually 120 VA. This is because the bulb has a power factor of less than 1, which we'll talk about in a bit, which means that it's consuming more apparent power than real power. So, why does this matter? Well, if you're working with electrical systems, it's important to know how much power is actually being consumed. This can help you design more efficient systems, troubleshoot problems, and prevent things like voltage drops or equipment damage. Now, let's talk about power factor. As I mentioned earlier, a load with a power factor of less than 1 will consume more apparent power than real power. This happens when the load has reactive components like capacitors or inductors that store and release energy. To understand power factor, let's go back to our light bulb example. If the light bulb had a power factor of 1, which means it's a purely resistive load, then the real power and the apparent power would be the same. However, since most loads have some amount of reactive power, the power factor is typically less than 1. So, how do we calculate power factor? It's actually pretty simple, just divide the real power, in watts, by the apparent power, in VA. The result will be a decimal between 0 and 1 that represents the power factor. And there you have it, folks, a brief overview of why apparent power is important in electrical systems. By understanding how to calculate apparent power and power factor, you can ensure that your systems are running efficiently and effectively. Thanks for watching. If you want to learn more about apparent power and other electrical concepts, be sure to check out my website electrical4uonline.com. You'll find more in-depth information and resources to help you further your understanding of electrical systems. The link is in the description below. And don't forget to subscribe to my channel for more videos like this. Thanks again, and I'll see you in the next one.